Well, hello, and today we're going to continue our study on systems of equations. Remember that systems of equations involve two or more equations simultaneously. That just means that they're together at the same time. So we figured out that you can do a linear programming problem with systems of equations. What we're going to do now is more generally talk about systems, not necessarily in an application. Now, you should have already done the warm-up where you were asked to solve y equals 3x minus 4 and x plus 2y equals 6. And specifically, you're asked to use the substitution method. Now, the substitution method gets its name for a reason because you take something that you know, such as what y equals, and you substitute it into another equation for, of course, that same variable. But when you do that, there's a number of things to keep in mind, namely that the variable y, in this case, is going to be replaced with an entire expression. So these parentheses, which we'll highlight in red, are essential because, of course, they require you then to apply the number 2 to each of those terms. Now we're going to just distribute or multiply, and now we have an equation with one variable x, that we can combine those like terms. You can also add the 8, that is, do the opposite, so you can add that and get 14. And of course, solving that, x equals 2. Now that's nice because it's right, but remember, if x is going to equal 2, well, we also need to know the y value that goes with it. And the cool thing about systems is that you can just take your answer and you can plug it back in to either one of the equations. Preferably the equation that's simpler, that would be the top equation, but you can plug in what you just found, that is that x equals 2, in for x, and that'll get you your y value. Of course, that's 6 minus 4, which happens to also come out to be 2. And now we have our final solution, which is a point. It's actually a point where these two equations would intersect. That is the point of intersection. But keep in mind that 2, 2 satisfies not only the first equation, but it also satisfies the second equation. Simply plugging in 2, 2 helps you see that that also checks to be 6. What if you don't have an equation that is already equal, that is equal to x or equal to y? Well, that's no problem, because you could solve one of your equations for x or y. Now, just so we don't think that we always have to solve for y, you can solve for x, that is, you can solve maybe the second equation for x, if we just do a little bit of inverse operations. So if we subtract 2y from both sides, we get negative x equals negative 2y plus 2. And then since we have a negative x, we can swap that negative sign to the other side, and now we can have x equaling positive 2y minus 2. So, yeah, now I know what x equals, and now I can plug that in to the other equation for x. This is also the substitution method. It's just showing you that you can substitute for x or y. Similar to the other problem, that's going to cause us to have to do a distributive property, and of course be very careful as you multiply and continue to solve your equation for, in this case, for y. Now I've got y in a couple places. I've got a 6y and a 1y, so that of course gives me 7y. If you add 6 to both sides, that'll get you 21. So now we know that y equals 3. Now you can take y equals 3 and you can plug it back into either the top equation, the middle equation, or even this revised version of the middle equation. Look at that revised version. It's pretty easy to plug in y equals 3 because it's already solved for x. So I can see that that would mean that x has to equal 2 times y minus 2, that is 2 times 3 minus 2. That's 6 minus 2 And of course, that comes out to be 4. Now be careful. X equals 4, y equals 3. We want to write that as an ordered pair as 4, 3. So a little review of the substitution method from Algebra 1 and geometry. But this is Algebra 2. So what we want to do is we want to solve some systems that are larger, like 3 variables, like solving for x, y, and z. Now the good news is we're going to do the same thing. We're going to substitute. What we just have to understand is that we have to do it twice. Whereas in the previous problems, we essentially substituted once and were able to solve for our answer. For these problems, we will have to substitute twice. Let me show you. First off, one of the equations hopefully has a variable that's easy to solve for. Most of the time, the answer is yes, okay, because we want to make these problems doable. So how about we solve that equation for y? How about we get this negative 2x over here? How about we get this 6z over here? We're basically just going to move those over to the other side. Now remember, when you move them over, you do the opposite. So it's actually now a positive 2x. It's actually now a negative 6z, but there's still a plus 1 over there. Okay, so we move those terms to the other side. What do I mean that we have to substitute twice? Well, simply, I mean that you're going to have to take the 2x minus 6z plus 1 that's shown here, and you're going to have to substitute it once, twice. Now, the reason you have to substitute it twice is because both of those equations are going to be required so that I can create a simpler system of equations. That's a little fancy, so let's do it, and then we'll kind of see why we're doing this. I'm going to do a little recopying of equation number 2. Sometimes students will label this. Maybe it'd be better if I labeled it as equation B. Maybe the first one is equation A. How about A, B, C? So here's equation B. Looks like a 13. Here's equation B with a little substitution of equation A. Now when I do that, yes, it looks a little more complicated at first. Just be careful that you're keeping track of your terms. So, you know, everything in parentheses looks like it's going to get multiplied by 2. So now I get double what I had. Everything gets multiplied by 2 in the parentheses. Again, it's looking rather large, but if you relax a little bit, you notice that you've got some x's that can add together. Of course, those like terms are 7x's, and I have some z's that can combine together. Careful with the negative, you get negative 7z. Now, this 2 and this 16, they're going to want to be on the other side. They're going to want to be together on the other side. So I'll subtract 2 to the other side, and I get 14. Now, I want you to hold on to this equation. And the reason I say that is because it is going to eventually become part of a simpler system. What am I talking about? Well, we need to do another substitution before we see. So now we're going to do equation C, and equation C has a y that is ready to receive the same 2x minus 6z plus 1, the same substitution. Okay, now make sure you're not just copying, but that you're noticing where these numbers, or really these expressions, are coming from. I simply substituted a second time into equation C. A little distributive property, hopefully being careful, because now everything is being multiplied by 3, so everything gets a little triple there. And kind of the same thing. I've got some like terms. I've got some x's that become 13. I've got some z's that get more negative, negative 22. And this 3 and 11, they want to be together on the other side. Please subtract 3. It's going to, of course, give you 8. Well, I also want you to hold on to that equation. But it's time to release them. It's time to use them as a new, simpler system. A new, simpler, let's put the word new. In other words, 7x minus 7z, minus 7z equal 14. That was my first one up there. And this 13x minus 22z equaling 8, that's my second one. I now put them together. I now have a simpler system, and the reality is it's time to start over. Not completely. Start over meaning that now I'm going to solve my new system. How do you solve your new system? Okay, well, that's a good question. How do you solve it? Using the substitution method. Using the substitution method again. Now, none of these equations are easily solved for x or z, but the top equation can be solved for x or z. If I solve it for x, I notice that I can just add 7z to the other side and then divide by 7. And if you divide by 7, thankfully, it works out pretty nicely to be just x equals z plus 2. What can I do with x equals z plus 2? That's right, you can substitute it. You can substitute it into the second equation. And finally, we're at a point where we are able to get an answer for z this time. But do you see? You have one variable. It took a while to get there, but I have one variable. I have an equation that contains just z's. Make sure you carefully add 13 and negative 22. I believe that that's negative 9z. Make sure you subtract 26. I believe that that is negative 18. Sorry about that, I got a little confused for a second. So we subtract 26 from both sides, we get negative 18. And shoo, z equals 2. Now, z equals 2, we're almost home free, but I need to take that and I need to continue to back substitute. I need to back substitute into previous equations so that I can continue to find additional values. Notice I was able to find x. The last thing is to go all the way back to the original system and substitute one more time so that you can find y. My suggestion would be that you substitute back into this one since it's already equal to y. And if you do that, you're going to, of course, put a number 4 beside the number 2, and you're going to put a, what do we get for z? A 2. You're going to put a 2 beside that minus 6. Don't forget your plus 1. And what do you think? 8 minus 12 plus 1 is negative 3. I'm going to keep track of all these answers. Honestly, we record them ultimately as one ordered, not pair, but ordered triplet, where x is 4, y is negative 3, and z is 2. And that is your solution. Yes, it takes some work, it takes some organization. Ultimately, we had to substitute twice, create a simpler system. All right, let's look at one more of these, so to speak, mega systems that have 3 variables. Now, this system, it may at first appear quite different, maybe even perhaps a little harder, but there's a reason that it's easier. Actually, there's a reason that this problem the reason is because this problem has an equation that already has just 2 variables. You see, really the whole idea with this double substitution is that we're trying to produce equations with 2 variables. So we will only have to substitute one time. Now, if you look at this equation again, I know it's pretty obvious that it has y and z, but what does it not have? That's right, it doesn't have x. That means that we need to substitute x. Now, it should be pretty clear that we have an equation of the form x equals, but I want you to realize that if you substitute x is going to disappear, and that's what we're trying to do. So if we call this equation A, B, and C, what's happening right now is we're going to substitute A into B. So that means that I have a Z, I have a 4, but I no longer have an X. That's because it's going to become this 3y minus 3z plus 8. And so we just substituted X. I still have the 5y and the minus 14. And if you kind of look over what we got here, even though it needs simplified, it's just an equation with y and z. That's great news, because that's going to match up really nicely with this bottom equation. Well, let's keep simplifying. Do the distributive property. Please do it carefully. You get 12y, you get minus 12z. You actually get 32. Let's try to write that 2 like a 2. I still have my 5y and my minus 14. Now, there are some like terms, right? There's a 12y, there's a 5y. So let's add those together. Of course, that's going to give you 17y. But there's also some like terms that are just like good old numbers, 32 and minus 14. So again, add those together, combine them together, and you just get 18. What do you think about this minus 12z? Do you realize that it is going to need to scoot over here with this z? Yeah, I mean, if we're going to combine like terms, then we actually want to move the minus 12z to the other side. It's going to give us a 13z. And speaking of moving numbers to the other side, this 17y, it really fits better on the same side with the variables. So we'll subtract 17y, we'll keep the 13z, and we'll keep the 18. Okay, that equation that I'm putting a green box around is an equation with just y and z, and it matches perfectly with the equations up above, which was equation C, that also has just a y and z. What we're saying is that we now have a new system. We have a new system. Maybe you don't need to recopy the whole thing. I'm going to, just to make sure we realize that my new system is now ready for a simpler substitution method. A simpler substitution method, in other words, I just need to treat this like some of those warm-up intro problems. The only problem is that neither of these equations have a really easy variable to solve, which is kind of a bugger, but I could solve the second equation for y. It's not the worst thing ever. If you just subtract 2z, and if you divide by 3. Now, the dividing by 3 is the part that's not super pretty because, well, it doesn't divide evenly. But I can take this now, let's put it in yellow. I can take this new equation and I can substitute it back in for y. Okay? Don't go back up to the big equations. We're done with those, at least for now. We just need to work on this simpler system. So we just got to grin and bear it. You got to plug in these fractions, unless you really want to change them to a decimal. Not necessary. We just need to trust that if we continue to solve, that is, do the distributive property and so forth, that things are going to work out. Now, negative 17 times negative 2/3. You could, again, put that in a calculator, or you can just multiply the numerators to get positive 34. Keep the 3, keep the divide by 3. I'm going to have to multiply negative 17 times 14. You get negative 238. I'll just write that as a minus sign. But yeah, you get negative 238. It's still divided by 3. Fun times. Eventually, you're going to want to combine your 34 thirds z with your 13 z's. Now, how do you combine those together? You can make a common denominator. That common denominator would be 3, but that means you have to multiply the top by 3. Or again, you could put it in a calculator, but it's basically just 34 plus 39, coming out to be 73 thirds. But that's 73 thirds of z. How about this 238? Actually, negative 238. How about we add that over here? Okay, if you add that over with 18, you're going to end up with 292. Okay. At the very last step, when you multiply by the reciprocal to cancel that darn fraction in front of z, when you get to that last step, these cancel out, you're just left with z, and thank you, these numbers multiplied together, it turns out that the 3's cancel, but the 292 divided by 73 comes out to be 4. And so we do end up with an integer, which is nice. Now, if z equals 4, you got to plug that back in to your one of your equations up here. I'd recommend that you plug it into the one that's already solved for y. So we're going to plug in the number 4 there. I'm going to have to scoot down to make sure that we have space for that, but that's just going to be y equals negative 2 thirds times the 4 that I'm plugging in, plus 14 thirds. Still got some fractions going on, but that comes out nicely to be 2. So y equals 2. And then all I got to do is take both of these answers. Again, my answer for z, my answer for y. And now we go back up to the very top equations. There they are. And we can find x. What do you think? You probably want to just plug into the very top equation because that one already is equal to x. So we'll get some space. Actually at the bottom of the screen, but I think I got enough space that we can do x equaling 3 times. We're going to plug in the 2 for y, and 3 times the 4 for z, and we'll add 8. X equals 2. Now remember, these 3 answers are a triplet. That triplet should be written as x, y, z. It should be written in order. Now, that's a substitution method with multiple variables. What you want to do now is you want to try the 4 problems that are available on the calendar. You're actually just going to be clicking and getting a PDF. You do not need to print that PDF. You can just copy those problems carefully onto a piece of notebook paper and work those out.